This is Kelly Hill, technology reporter for RCR Wireless News. I'm here at the 5G Innovation Summit with Joy Laskar of Maja Systems. That's right. Okay, so give us a brief introduction to what you guys do, and tell us a little bit about your perspective on 5G.
Sure. So we're Maja Systems. We're a startup here in Silicon Valley. We're about 3 years old. We just launched a product beginning of this year. What we do is basically build millimeter wave CMOS digital radios that are co-designed with antenna. And we're sort of ahead of kind of the 5G standards, et cetera. So currently we're building product at 60 gigahertz, developments at 70, and lower frequencies. And the use case is basically low latency, high data throughput types of links for a variety of applications. But you can imagine anywhere someone wants to have an Ethernet-like connectivity, but do it wireless. From our perspective with regards to 5G and what's going on here at the Innovation Summit, we're really focused on the physical layer type of implementation. And one of the big challenges historically at these frequencies is 70–80% of the cost structure is really around assembly and test. So much of what we do is to try to attack or solve that problem for our customers, and working closely with folks like Rohde and Schwartz and others, right? But what that really means is that the radios or the radio solutions will be for 5G or precursors to 5G are going to be highly integrated, probably a lot of CMOS content, and one can imagine where you have a lot of digital hooks into the analog or radio solution that you can not only program set points, things like that, but where you can verify operation without going through a lot of manual interjection.
Interesting. What are you seeing in terms of sort of the, I don't know if you might call it consumer mobile or consumer type or even enterprise applications versus something like IoT? Do you see development happening in both spheres?
Absolutely. In fact, the way we've been interacting with the market is we've developed a fairly robust what we call reference kits, and we sprinkle them out there, and then people come back with applications that we never thought of. So absolutely on the IoT side, we're already seeing what we would call machine-to-machine type of interaction. One example which we're designed into and ramping in volume right now is for industrial or harsh environments. So you can imagine on a manufacturing line where you have robotic arms, and there's actually a fair amount of information moving back and forth to the edge of these moving pieces. And one of the main failure rates is the data cabling breaks, and that's a very expensive downtime, right? So the customers basically want to architect a multi-gigabit wireless harness replacement, right? And so that's it's IoT in a sense. It is IoT, but it is not a typical kind of wireless use case, right? Because you have very low latency, meaning sub-microsecond. It has to be fairly robust, and carrying wire-like data rates, right? So that's one type of, and you can imagine the extension of that, right? So as that type of use case matures, harness replacement in general, there's a lot of examples where that goes, right? So that's one. The other is around consumer connectivity. Lots of discussions going on. What we hear, people really want two types of things, right? One is as high a data throughput as possible, meaning following like an Ethernet roadmap. So people are already asking for, can you do 10, 12.5 gigabit, et cetera. But it, with low overhead, meaning your additional power budget, it cannot be a multi-watt solution, right? And it also has to be, in a sense, plug and play. So whatever the solution is, there's already existing sort of infrastructure, so you have to sort of ride on that. But so one is throughput, and then the other is the ability to with not much human intervention for a link. So auto alignment, phase array, all these types of things. That's clearly a sort of becoming a must-have for some of these ubiquitous use cases, right? The big ones are data rate, the ability to self-align, and then once you start to do that, you're starting to build all the pieces of a radar. Right, and there's different types of radar, not only for things like automotive, et cetera, but also sensors. Right. So, what we used to think might have been research projects or gee whiz type of things just a couple of years ago, folks are really evaluating it. And here in the Valley, I think it's not an exaggeration to say that pretty much all the large consumer companies are looking at millimeter wave in some form across those types of use cases.
Oh, well, then we should see a lot of development in the next couple of years.
I think so. In all seriousness, absolutely. Yeah.
Okay.
Yeah.
Great. Well, Joy, thanks so much for your time.
Thank you.